Hello and welcome to this new video. Today we are going to talk about Linux from nothing, how to make the internet work from scratch. Coming up. So yes, today we will be making the internet work on a very simple Linux distro. So if you haven't seen the first video, that's no issue, you can still follow this one. I have the image online on my website, maplecircuit.dev, so you can download that and be able to follow this video. Now, our goal is to be able to download stuff from the internet and hopefully download source that we will be able to compile next video to be able to make our distro self-sufficient. So it won't need any external thing throwing software into it like we're doing right now, right? Because right now we have an image, we're throwing programs into it, and it's really not perfect because sometimes we maybe can miss a dependency and everything will crash, or there's a bunch of reasons why compiling software on one machine and just throwing it on the other machine is not optimal if you don't know what you're doing, which we don't. So let's try to get to the step where we can compile everything locally as fast as possible, and this is the first step towards that. So let's actually get the internet to work on our system. Let's start by installing the dependency for today, which is libcap. We don't necessarily need it, but if you want to follow the tutorial as perfectly as possible, just download libcap. It's going to do all the magic, okay? So for now, ignore libcap. We're going to talk about it a little bit later. So let's enter our LFN project directory and let's start by creating a loopback device like we did last time, and to mount the partition inside of our disk image onto /mount. So now we can actually access our project in /mount. Now our first step to actually get to anywhere online will be to use IPRoute2. IPRoute2 is the default network tool for Linux. So whenever you want to edit some network connection or do anything, IPRoute2 is kind of the place where everything's implemented so that you can tinker around in there. So we obviously need that. So let's clone it. Let's enter the IPRoute2 directory that was cloned, and let's run the configure command using libbpf force off to deactivate libbpf. Well, we don't have BPF at all, so we don't want that to be enabled on our system. And let's tell it that we want to install all of our thing into the /usr directory. Now, just to give you some more detail, last video I've shown a lot of software that you could easily configure from another directory. That's not the case for every software that uses configure, that it can actually be configured to another directory to be compiled onto another directory. And IPRoute2 is one such software that you actually need to configure inside of the same directory that everything is in. So that's why we're doing it that way. You're going to see there's both those that do and those that do not work with a configure that can be done outside. We're going to show it. We're going to download a lot of things in this video. So let's get going. We need to actually change the config file for IPRoute2, which is named config.mk. We're going to use nano, and we are going to change the have SE Linux. Of course, we don't have SE Linux on our system, and we don't plan to for now. So let's put that to no, to N. And let's save that. Let's do make-j8 or the number of core that you have. I'm going to say make-j8 throughout this video, but you can always use the number of core of your machine in order to tell make that you want to compile with that number of core. Once the compiling is done, let's just start by having a bit of a brain and check what are the libraries that are missing to be able to run that software. So let's use the ldd command on IP/IP, which is exactly the place where the IP command is. And what it will show you is that we need a bunch of things to make that work. Now remember that right now we are on our host computer, so it will have everything that we theoretically need, but that's not the point. We want it to work on our LFN system. And to be able to check that, we need to compare inside of our directory to see, oh, that one we have, that one we don't have. I already done all that. There is 4 things that we're missing. We're missing libelf, we're missing libcap, we're missing libz, and we're missing libz standard or libz std. So let's actually install them. Now, right before we do that, let's just complete the installation of iproot2, which we need to do the sudo make desdir /mount. Now that's the different part, right? We're not pointing to the root directory that we had on the last tutorial. We're pointing directly to /mount because now that's where it's mounted, right? The root directory that we had, you can ignore it, you could delete it. It would not change anything to what's going on because right now everything is working out of /mount. So let's do that install and let's get out of the iproot2 directory. So let's start installing those dependencies that we need. Let's start by ElfUtil. ElfUtil is a simple tool that's made to edit binary. So most binary will use elf in order to give information or have dependencies or for a bunch of reasons. So having ElfUtil can be used for us or for a bunch of programs that may need it. So let's start by cloning it straight from the Git and entering the ElfUtil directory that was created. Now, ElfUtil has a weird thing that we need to do in order to start configuring it like we would do for any other project. We need to do auto-reconf-i-f. Now, auto-reconf is a command that's there to be able to create a configure file out of all of the file that this program has. Now, the -i command tells it that if it's missing any file, it needs to recreate them, and f tells it that if a file is already existing, it should delete it and create a new one. So that way we will create a brand new configure file that we will be able to use to compile the software. Now, once that's done, let's get out of that directory and let's, like all of the other project that we've done, make a new directory called ElfUtil build. Let's enter that ElfUtil build directory and let's configure it with the enable maintainer mode and the prefix being /usr. Now, enable maintainer mode kind of triggers a bunch of things inside of ElfUtil that allows us to compile it. Without it, it doesn't work. I don't know why, but it just doesn't. So just make sure that you enable maintainer mode. And of course, we're going to do our make-j8, and right after that, our sudo make desdir /mount install to get it to the right place. And let's get out of that directory. We've got ElfUtil actually done. Now for LibCap. LibCap is a library that's there to change a little bit how privilege works. I'm not going to go into the specifics, mainly because I don't know them, but from what I understand, it gives permission to programs and not users, which allows a bunch of things to happen after. Anyway, it messes around with permission and privilege, so we need it. So most distro will have it by default. Anyway, let's get going with this. Let's do git clone and let's enter the libcap directory that we've created. Now, libcap is a very simple piece of software. We don't even have a configure to go through. So let's do the make-j8 and right after the sudo make desdir /mount install to install it at the right place. Yes, there is no configuration at all. It will already drop everything at the right place. So it's the simplest software that we will compile today. So let's get out of the libcap directory and let's get to Zlib. Zlib is a compression library that provides libz. So we are going to be able to download it using wget and then extract it using the tar command. Now, some people have given me what z is. So x is for extract, v is for verbose, z is for it's a gz file, and f is the actual file that it's pointing to. So we are starting to learn whatever the option do on a tar command. That's great, right? Let's get to the make dir zlib-build and enter that build directory. Now let's go into the configure inside of the zlib directory that was decompressed and configure it using the -- prefix /usr directory. So very simple, no real modification here, we're just throwing things at the right place. We can do the make-j8 to compile the stuff and do sudo make desdir /mount install in order to throw all of that right to our mount directory and get back out of that directory, of the zlib directory, using cd .. Now, as you can see, we're going to go very fast through them because there's a lot of them, but yes, no need to go deeper in them, right? Because it's just a library that's there for compression. And same thing for the next library, right? We're going into Zstd or Zstd, which is itself another library for compression, and it also contains program that can be run to compress or decompress ZST file, GZ file, XZ file, or LZ4 file. So again, we're just going to add that library because we need it, but there's actual program that could be used here. Let's use the git clone command to clone the latest version of Zstd, and then let's get into the Zstd directory using cd. And again, that's a very simple library, there's no configuration here, so let's do make-j8 to actually compile it. Now here, hold up, you have a quick modification to your usual code. So you're going to do sudo make this_dir/mount. But here you need to add prefix equals /usr. The reason why you need to do that is that by default it would throw things into the usr/local directory. We don't need that, we don't want that, we want it right at the right place. No need to install it in its specific directory. Let's make it at the right place the first time, and that's what prefix /usr does. So again, prefix /usr, install, and then we have it installed to the right place. We can then back out of Zstd directory. Now let's actually test it. Let's test it for the first time. Let's sync it a little bit and then unmount/mount. Now, technically you don't have to sync it, but I like to sync things before I unmount things. We never know, right? So you unmount, then you destroy or detache your loopback device. So sudo lo setup-d/dev/loop, your loop number, just to make sure that your loop is down. And this is actually very important, right? Because last video I flirted around with the idea that, oh, if you sync it should be okay. That's not true, okay? I've tested it. It's not true at all. Sometimes, for some reason, I think that it's between the kernel and the loopback device. The sync doesn't happen there. It happens with the file system and the loopback device, but it does not happen with the loopback device and the file system that's under it. So you see how you could lose some data if you have QEMU reading the actual disk file while all the things are not written to it because the loopback device is kind of holding a little bit. So sync is not enough. You really need to go down the list and go destroy your loopback device before you use the QEMU command. So let's do QEMU system x8664, our disk image, and let's go and actually try our IP command because that's what we've downloaded, right? So let's go and do IP. And what do we see? We see cannot open netlink socket, function not implemented. Now, whenever you're adding software, it can be very common that that software will actually need some kind of kernel option. Now, if you've used a standard kernel and not a minimal one, not a one that has been compiled using tinyconfig, you should not see that error. But for the people that have followed faithfully this tutorial, you should see that error, and that's just because we have not enabled the right function into the kernel. So let's actually go and enable all the options that we need in order to get all the function needed for the internet. So let's get started by mounting everything back up. So sudo lo setup-f P-show disk image, sudo mount our dev loop to /mount. So now we can once again throw stuff into /mount, and let's go into our Linux directory and make menu config. Now, right before I continue here, if you're just new here and you're following from this tutorial, you should go ahead and follow the first part of the tutorial. Of course, it's on the website. Just follow the Linux part, right? Just to have the kernel set up with the right options to be able to follow this part, because if you only follow this part for the kernel, it's going to make no sense. Your kernel is not going to work. So you need to follow both the kernel number 1 and this kernel in order to make it work on your machine. But let's just get going with menu config and let's actually configure that kernel for the internet. So first of all, let's go down general setup, configure standard kernel feature, and enable Vutex support. Now, Vutex is the short for fast mutex. It's used all over pretty much everything web related. So the goal of a Vutex is more or less to tell the system that one core or one program is already doing something and to wait until this program or this process or core has done doing something in order to continue running whatever you're running. So it's in most cases just to hold on to the system to tell it to wait until we're ready for the further instruction. So fastmutex are a user space thing. Well, they're of course handled by the kernel, but they're still a user space thing. Anybody can use them. So let's just go forward and continue configuring our kernel. So let's go back to our root and go into general architecture dependent option, where we will provide system call for 32-bit time t. Now, a bunch of network program will use 32-bit time, so we actually need to enable it into the kernel so they can seek it from the kernel. Now let's get back out of there and go into networking support, which we will enable, and then go into networking option. Inside of networking option, we have three things we want to enable. First is packet socket. It's used by a lot of things throughout the Linux world, so I'm not sure if it's Unix domain socket or packet socket that we need today, or both, but anyway, it's used throughout the Linux world, so let's enable both. And also enable TCP/IP networking, so that we can have everything needed to make our system run network-related task. Now let's go back out of there and go into device driver, where we will go into network device support, enabling it, and let's go down to Ethernet driver support, which should be already enabled, and enter it to go down to Intel Pro /1000 gigabit Ethernet support. Now, the reason why we are enabling this one precisely is because QEMU actually uses an emulation for exactly this card. So it uses an E1000, I think it's the name of the driver and the card. So E1000 need to be enabled, that's E1000. So get that enabled so that QEMU can actually run, and then we can go back out to the root and go down file system and enable iNotify support for the user space. One of our last program that we will use will actually need iNotify. iNotify is just a way to see change into a file. So it can monitor a file, give you information about that file without continuously seeking it. So it can be useful with some config file for a given program, but all you need to know is that it needs to be enabled. Once all of that's done, we can go back out, do our make-j8, and do sudo move arch x86 boot bzimage, and throw that straight onto our /mount/boot, where it should overwrite our already existing BC image. So that way we will boot automatically on it without further modification. Let's go back out, let's sync, and let's, of course, unmount our /mount and destroy our loop so that we can actually safely execute QEMU and start actually enjoying the IP command. So let's try IP, we see that it works, and let's try IP link, which will tell us some information about what is on the system, what are our network connectors on the system. So we see that, we see them, that's nice. We can start actually installing things that will allow us to download things, because right now we may have the technology to get on the internet, but we don't have the technology to seek things on the internet, to get things down from another server. So let's actually install that, let's make that work. Again, we need to mount everything back up, so sudo lo setup with our disk image, and sudo mount our dev loop that we've created, and /mount. We once again have /mount that we can throw our things into. So today we will use Wget in order to go onto the internet and seek things, and at the end actually download a maplecircuit.dev page. So let's get started by using Wget. So let's use Wget to actually get the latest version of Wget. Let's use star to decompress wget-latest, and let's make dir a wget-build directory. Let's get into that wget-build directory, and let's use the configure command to actually configure wget. Now we want with SSL equals OpenSSL because it actually has the choice between OpenSSL or GNU TLS. I'm not a fan of GNU TLS, I prefer OpenSSL, I have experience with OpenSSL, so let's actually use that version and of course use the -- prefix equal /usr to install it at the right place. Once that's done, we can do our make-j8, our sudo make desdir /mount install to get it at the right place, and let's do just like we did for the last software that we downloaded. Let's do ldd /mount /bin /wget to see what libraries are needed in order to make that software work. So here we can see that there's a couple of libraries that we don't have. We don't have libpcre2, we don't have libSSL, and we don't have libcrypto. Now, let's just parse a little bit of what we see here. libpcre2 is a regular expression pattern matching, so that's something that we will need to download, and libSSL and libcrypto are both the same thing. Well, they're not the same thing, but from the same place, they're from OpenSSL. We are going to need to download both of those in order to make wget work. So now we can back out of our directory so that we can install pcre2. So like I said, pcre2 is there to be able to parse regular expression in our terminal. We actually need this. Well, wget needs this in order to parse them and be able to do whatever you want to do with your complex regular expression. So let's actually get started with git clone where we download pcre2. Let's get into pcre2 because that library needs to do an autogen. So let's do a /autogen.sh. Once that's done, cd ... so we back out of there and create our pcre2-build directory. And let's go into that pcre2-build directory so that we can run the configure command right out of the pcre2 directory and use it with only the prefix option. Once that's done, we can do make-j8 to actually compile the library, and after that, most people would actually do make install, but for me, for some reason, it doesn't work. But turns out that we don't need to do make install for that software because they've hidden all the libraries into the .libs directory, so we can just do sudo move .libs /*mount/lib so that we can use that command that pretty much says, hey, get everything inside of the libs directory and throw it into the lib directory inside of /mount. So with that, it will do exactly the same job as it would using make install. So we're all good, right? And then we can cd out of there, cd ... to get out. Now we can get onto OpenSSL. Now OpenSSL, you've probably seen it a little bit everywhere because it's the king library that's used everywhere for everything that has to do to SSL, TLS, your HTTPS, your whatever encryption that you need or cryptography. It's probably handled by OpenSSL somewhere, or it can be handled by OpenSSL. So let's download it using git clone and then create our OpenSSL-build directory, and let's enter that OpenSSL-build directory. Now once again we can configure it using the configure command, but just make sure that you put a capital letter on the C because for some reason they've capitalized the C of configure. So go figure, you need to capitalize configure and then do -- prefix /usr. Now with that done, we can do make-j8 to compile that software and do sudo make desdir /mount install to install it at the right place. And once again, back out of there. Now let's just automate a few things to be able to connect to the internet, because right now, even if we have the capabilities to go on the web, we need a few commands to tell our system where to go and how to do it. So let's do sudo nano /mount sbin init to edit our init file that, of course, initialize at the same time as we boot, so it will tell the system how to actually connect to the internet. So we are going to add a few commands into it to make it work. The first thing that we are going to do is to do the IP link setup eth0. Now, if you remember when we did the IP link command, it told us that we add an eth0, which is our default network connector. So doing the setup command actually enables and turns up the ETHO network connector. Then we are going to do IP address, or ADDR, add 10.0.2.15/24. Now those numbers only work with QEMU because those are QEMU specific numbers. If you were to set this up on your own network, you would put whatever IP address is free for you to claim from your router. So that's just the actual IP address that we should use in order to connect to the internet. That's our own local IP address. And we do dev ETH0, which just tell the system that it applies to ETH0. Now let's also add the IP route add 10.0.2.2 dev ETH0. What this command does is it tells the system that there is a route that exists through 10.0.2.2. Turns out that IP address is the gateway that's provided by QEMU. So QEMU kind of emulates a router, and to go through the gateway of that router, we need to speak with exactly that IP address. So we, by using the IP route add, declare that this route exists. Now what we need to do is to use yet another command and to tell everybody that it will be using that route. So we do that using the IP route add 0/0 via 10.0.2.2 dev ETH0. Now, I know that I've made a mistake in the video. I think I put VO and then I kind of see it and I edit it. So you're probably going to see that right now. But anyway, while I'm explaining, 0/0. So what we're telling the system here is we're saying, hey, every address that you're trying to reach, I want you to throw it at 10.0.2.2. And this makes sense because at a very basic level, the internet is just a bunch of people asking the same question. The question that they're asking themselves is, am I the one to manage this request? And if not, where do I need to throw it? This is the internet. When they say it's a series of tubes, well, that's what they mean, right? Because they're always asking, what tubes should I throw the packet in, or should I myself be actually taking care of that packet? And here we're answering the question, and we're answering it by telling it, you're always throwing it to QEMU through the gateway. So once that's done, we can save it, do the syncing, do the unmounting, do the deletion of the loopback device, and actually execute it, where we will see that using wget will still end up in failure. But let's actually read the error that we get. Resolving maplecircuit.dev failed. Temporary failure in name resolution. Wget unable to resolve host address maplecircuit.dev. So here name resolution and resolve host address actually gives us all of the information that we need to understand what we are missing. Here we are missing the ability to know what maplecircuit.dev points to, and that's the job of a DNS server or a DNS resolver. So let's actually mount everything back up using LOSetup and then mount the dev loop to /mount, where we will install DNSMasq. Now, DNSMasq is a small DNS server. It can also do a bunch of other things. It's a really great piece of software, and it actually was used pretty much universally before. And when I say before, I'm talking about before Systemd, of course. When we're dealing with very small Linux distribution like we're doing, you will see why some people hate Systemd. It's because, well, everything is now connected to Systemd now, so of course DNSMasq not being a software that's connected to Systemd, it doesn't have the same advantages of the newer version of whatever resolve software that's used today that's connected to Systemd, so it goes to the wayside, which is what happened, right? Nobody uses DNSMasq, you're using whatever is new that's connected to Systemd, but that's, in my honest opinion, all okay. You can go in the comment and debate it if you love Systemd like I do, or if you're a Systemd hater and yelling at the rooftop that Systemd sucks, you can too. Both can exist. I'm enjoying this, okay? Just yell at each other in the comments. I'm always enjoying the debates. Anyway, let's actually go back to the subject at hand using DNSMasq. So let's install it again using git clone, and let's enter that DNSMasq directory. Again, DNSMasq is probably one of the simplest software around to actually do a job. It's perfectly follows the keep it simple, stupid philosophy. So we do make-j8, and right after that we can do sudo move source/DNSMasq right into our bin folder, because yes, it's the only thing that we need. So we can now throw that straight to the bin folder, and let's get out of our directory. Now let's actually edit our init to include DNSMasq inside it. So let's do that by adding DNSMasq-u root. So the -u root is just to tell the system, hey, I want you to execute as root. Now, is this safe? Not really. DNSMasq is supposed to be executed as nobody, which is the user that you use with 0 permission, because that's his job. But let's just ignore the safety hazard of running DNSMasq as root. We're not here for safety, we're here to just make things work, right? So let's run DNSMasq as root, then save your init, sync, unmount, detach your dev loop device. You must be done by now, done messing around with that, and then do qemu system x86-64 to your disk image, where if we look at when our system boots, we see that DNSMasq has no user that's named root. Now your brain may be splitting atoms at this point, being like, what the hell are we if we are not root? Well, turns out that right now there is no user. Yes, there is absolutely no user on our machine. The reason why that is because we don't even have a password file. So if we go and do nano/etc/password, we see that we didn't have a file before, and we need to fill it out with our own content. Now, turns out you don't really need a user add command in order to add any user. You just need to add the user to the password file, and you should be good to go. So let's actually do that. Let's do that by answering all of the questions that it asks. So let's actually read what it actually does, right? So first we have root, which is the username. After that we have X, which is password or lack thereof. And then we have 0, which is the user ID, which is common. Root is supposed to be 0. Then we have the group ID, which is again 0. It's supposed to be 0. It's root. And then we have the user ID info, which acts a little bit more as comments, right? So we're going to say root, but you could write pretty much anything you want in there. I don't think it changes much. After that, we have the home directory, which is /root, and we have the login shell that it should use, which in our case is bin bash that we've already been using. Now, once that's done, we can save that file, and let's take 5 seconds to actually make a /root directory, because we don't have a /root directory, right? We should actually make that /root. So let's make dir /root, and let's test once again DNSMasq. Now, if we test DNSMasq once again, it will tell us that it failed to open PID file /var/run/dnsmasq.pid. Now, there's only one logical reason why it could fail to open something. As we are root, it can only fail because the directory doesn't exist, right? We're root, we should be able to open whatever the hell we want. So let's make dir /var/run to create the directory that is missing. And while we're at it, just because I don't like running things again and again while I know that they're not going to work, let's actually give the default name server to DNSMasq. So let's go and edit /etc/resolve.conf that need to be filled with name server and the address of the name server that we are going to be using. So I'm using here the Cloudflare one. You can use the Google one with 8.8.8.8. There's a bunch of well-known one, but I like the Cloudflare one. So nameserver 1.1.1.1, and it will tell DNSMasq that if it doesn't already know an address, it should go look to that address to get its new DNS detail. So if you ask it, hey, do you know what google.com is? It will go ask that address because it doesn't know at the start, and when it knows, it will just locally resolve it because it already knows it's in memory, right? So once we've done that, let's just save it, let's sync it, and let's restart our LFN. So of course, it's really important to sync here because we're literally crashing our system in order to reboot it. So let's sync it, reboot it, and let's now try wget with maplecircuit.dev, where we see that it actually it kind of connects, okay? It connects, it says that it cannot verify the certificate because I'm using HTTPS. Obviously, we don't have any authority, we don't have any certificate verification on our system. Let's just ignore that for now, okay? Can we be happy for the fact that we can actually go get data now? So let's do -- no check certificate, and we will see that it actually downloads. And now we can do nano index.html where, hey, once again, it actually downloaded things and we can now have access to the internet from our LFN. So was it that hard? Well, kinda if you don't know how to do it the first time, but it kind of becomes intuitive, right? You have IP that's here to actually give you the tool to link yourself to the internet. After that, you have DNSMasq, which is there to actually resolve the name that you get from the internet. And then you can add whatever software you need in order to, well, literally get data from the internet. So it could have been Kernel. I love Wget, so loving Wget means that I'm going to use it, right? So that's what we get. Now with that said, thank you, okay? Thank you for following the video, and let's make the secret comment of the day be systemd, because truly if there's something that can make you understand the systemd haters is to be messing around with small Linux distros, because what happens is that most of the time you're going to try to emulate whatever system you're running, and at that level you're going to see that everything is managed by systemd at some point or another, and that's probably going to be the 4th episode because, well, we need to have a real init, right? We need to have that system to work, and everything uses it. So we're gonna need to install systemd at some point. So systemd is the word of the day. Put it in the comments to show how much of a Chad you are. So once that's said, thank you a lot for watching. If you love it, show your love in the comments, show your love in the likes. Always appreciate it. Not going to stop. Next video will be GCC, make, git. So we're going to download all of those, make sure that they work, and probably some more, maybe Meson and Ninja. Anyway, let's not put too much pressure. We're going to go into those, and we're going to be able to have a self-sufficient distro. So let's look forward to what's coming up, and as usual, take care.